Hello everyone. In the semester 1, we have already discussed volumetric analysis. In the part 1, I have explained how to prepare standard solution, what are the important points and what the care should be taken while preparing standard solution. In the second part, we have discussed one exercise of succinic acid against X normal NaOH. There is one more exercise, almost similar kind of exercise. Few differences are there that we will discuss in this video. So that is oxalic acid against X normal NaOH. Both exercise are between the weak acid against strong base. Both succinic acid and oxalic acid, they both are weak acids. NaOH and KOH, they are strong base. So first of all, the main difference is the preparation of standard solution because the weight would be different. So this is the aim. Prepare 100 ml 0.1 normal standard solution of oxalic acid and determine normality, gram per liter and molarity of X normal NaOH solution. Now already we have discussed in part 1 that whenever we want to prepare normal solution, we must know equivalent weight of that substance. As we want to prepare standard solution of oxalic acid, so first of all let us calculate equivalent weight of the oxalic acid. So formula of calculating equivalent weight is molecular weight upon basicity. This is the molecular formula or structural formula of oxalic acid. Two COOH groups are joined with each other and we are using here hydrated oxalic acid. So oxalic acid accompanied with 2 moles of water. Sometimes if it is uh, uh, non-hydrated oxalic acid is used, then there will be little bit change in the weight. But here we are going to use hydrated oxalic acid. So molecular weight is uh, formula weight of 1 COOH is the 45. So 45, 45, 90 plus each water molecule, its molecular weight is 18. So there are 2 moles, that's why 36. So molecular weight of hydrated oxalic acid is 126 gram per mole. If it is non-hydrated, in that case, its molecular weight will be only 90. Now oxalic acid, you can see that there are 2 COOH groups. So on the ionization, it will give 2 moles of H plus. That's why its basicity is 2. So its equivalent weight would be 126 by 2, that is 63 gram equivalent. So if 126 gram oxalic acid, that is its molecular weight, if it is dissolved in a 1000 ml solution, then it is called 1 molar solution. And equivalent weight, that is 63 gram, if that is dissolved in 1000 ml solution, it is called 1 normal solution. So if we write the mathematical expression of this discussion, then we can write that this way. If you want to prepare 1000 ml 1 normal oxalic acid, you should dissolve 63 gram. But if you read the aim again, we want to prepare only 100 ml and zero point 0.1 normal. So 100 ml 0.1 normal oxalic acid if we want to prepare, that require 0.63 gram. How can we calculate? It is simple mathematics. 100 multiply 0.1 multiply 63 divide with this 1000. Or if we can convert this into milligrams, then it will be 630 milligram. So thus, uh, after weighing this 630 milligram oxalic acid, how to dissolve it thoroughly in water, transfer into measuring flask, what are the care should be taken, all these points I have discussed in first 2 parts. So directly if you are watching this, then first go through the first part and second part. Now quickly we will go through the experiment. This is aim again. This discussion we have discussed already. Procedure. As this is the titration between the strong base and weak acid, so we are filling base into the burette. We are pipetting 10 ml standard solution of oxalic acid from the flask and transfer into the conical flask. We are adding phenolphthalein couple of drops as indicator. We first measure pilot reading, that is also discussed in the previous videos, how to measure pilot readings. At endpoint we are getting light pink color, so that way we are getting the burette reading. This is the equation: oxalic acid 1 mole plus 2 moles of NaOH. Both these hydrogens, they are displaced by sodium, so we are getting sodium salt of oxalic acid, which is called sodium oxalate, plus 2 moles of water. We are writing pilot reading here, and we are taking 2 or 3 readings. If you are getting both the readings same, then without measuring you can write it here, but if there is a change in first 2 readings, then better you should take the third reading. And then we are reporting here constant reading, that is our burette reading V2. This calculation is, I have discussed in detail in a second part, but quickly let us discuss. With the help of N1 V1 equal to N2 V2, we are calculating normality. N1 V1 is for acid, N2 V2 for base. So acid's normality is 0.1, V1 is 10 ml, we have pipette out 10 ml, N2 we want to calculate, and V2 is burette reading. So that way we are getting normality. Gram per liter is normality, this multiply equivalent weight of NaOH. Make sure that in the calculation use the equivalent weight and molecular weight of the unknown substance, because that is your aim. And while preparing standard solution, use the molecular weight and equivalent weight of the substance whose standard solution you want to prepare. So sometimes students make here mistake. Here you are calculating about the NaOH. So use equivalent weight of NaOH, that is a 40. And molarity is normality into equivalent weight upon molecular weight. But in the case of NaOH, both are 40. So 40 would be cancelled, and whatever the normality will be molarity. Only difference, whenever we report normality, you should write capital N, and when you write molarity, you should use capital M. So almost similar kind of exercise. Technically it is the titration between weak acid and strong base. So I hope that you understand it.